Howdy everybody, it's Miss Kosh. I wanted to follow up on the previous video that you needed to watch. So what I have here is this top area is the end of my notes. And then I also looked at the way Miss Deloach explained things, and I pulled that in as well. So I want to talk through her notes. So you can go grab that out of Schoology or not, it's your choice. But the previous video, the bell rang and I got cut short. So here we go. I think it was last year. I don't know. But anyway, it wasn't enough. So let's talk about this. First of all, when we talk about the inverse notation, I just want to make sure that you're aware that these two things are used interchangeably. So the inverse, and it's cosine raised to the -1 of x, but it's a little bit tricky when you think of, like if you have x to the -1, that's equal to 1 over x. Well, cosine of x to the -1 is not a notation that we use because, if we try to do the same example, then this becomes 1 over cosine of x, which is secant of x, which is not the same thing. Okay, so we're never, ever, ever going to write it that way. Okay, and when they say cosine to the -1 of x, they're not trying to say secant. So what we're trying to do is we're trying to undo the action of cosine. So we're finding the inverse of cosine. This is the inverse. This is the reciprocal. Anyway, reciprocal with an L. There we go. So don't confuse the two. And in a little bit, we're going to get to where we have something like cosine of x that gets squared. And we write that notation as cosine squared of x. So some of it doesn't exactly make sense why this notation right here doesn't behave the same way as it does here, because this does mean it's squared, but I'm getting lost in the weeds. So let me not do that. Let me just tell you, though, that there's a huge difference between the inverse function and the reciprocal function. So these are used interchangeably, and arccosine means the same thing as the inverse of cosine. And when you want to, you have to, there is no arccosine button on the calculator, but there's this cosine to the -1. All right, so I liked how she described this first couple things. So it says, write each equation in the form of an inverse relation. So basically, this first one is saying sine of x equals -1. So if we were going to say arcsine, what are we saying? We're saying, this is saying arcsine of -1 would be equal to x. Okay, so in this case, another way to think about this is x is our angle. Okay, so we're trying to find what angle, sine of what angle equals -1. So we would say arcsine of -1 is going to give us an angle as an answer. Okay, so in this particular case, we have answered the question. In this particular case, when I think about arcsine, what am I doing? Where'd that line come? Okay, sorry. It's down here. The answer to that, x would be equal to 3 pi over 2, but they didn't ask us to do that. This other one right here is saying, okay, if root 3 is equal to tangent of x, how do I change that to talk about arctangent or inverse tangent? So this would be tangent to the -1. I wanted to use both notations just so you can see that you can interchange them. Of inverse tangent of, I keep hitting things funny, I'm so sorry, is equal to x. Okay, so far so good. And now we're looking at this. Okay, so there's the question. Arcsine of -1 we just said was 3 pi over 2. Arccosine of -1/2. Now keep in mind, oh, you know what? Let me pause and come back to my notes. So what we have here, and I started to talk about this, I said in the previous video that this one gave us infinitely many answers, whereas this one just gives us exactly one answer. And that's because the arcsine, or inverse sine, has a restricted domain, and so its range is only going to go from -pi/2 to pi/2. Okay, if you think back to what that graph looks like, that graph goes from here, it has these 3 points that we care about, and those points are, this is the point -1, -pi/2, this is inverse sine. This is the point 0, 0, and this is the point 1 pi over 2. That's it. That's the whole graph. It doesn't do anything else. And so its range is restricted to negative pi over 2 to pi over 2. If you think about this in terms of the unit circle, what we're doing is we can only live in quadrant 1 and quadrant 4 if we get to quadrant 4 the negative way. Okay, so we're going to go from negative pi over 2 to positive pi over 2. So anytime you see arcsine or inverse sine of something, you can only give me an answer that goes from negative pi over 2 to positive pi over 2. If you're in degrees, you'd be from negative 90 degrees to positive 90 degrees. Okay, so if you try and tell me anything else and it doesn't fall in that interval, you're wrong. You're just, sorry, hate to say it to you, but you would be wrong. So on this one, all values of theta when sine equals root 3 over 2. Okay, so back to the unit circle. That's here and here. And so to find all of them, theta would equal to pi over 3 plus 2 pi k, and theta would equal to 2 pi over 3 plus 2 pi k, where k is an element of the integers. And there's infinitely many answers. If you think about the sine curve, it's hit that value infinitely many times. However, this one right here, it must be the answer that you can give it is, let me try that again. You only get one answer, and that answer is the one that's in that range from negative pi over 2 to pi over 2. So when you think about the unit circle, we're looking, okay, what did I get? Well, I hit it right here, which means that the only answer to this is pi over 3, and we're done. Okay, so now, you know what, I'm going to jump around. I'm going to go back to Ms. DeLoach's stuff. So here, arccosine is now going to, if you think back to, let's do what we did right here for arcsine. Let's do that for arccosine. So let me come down with arccosine. Okay, if I have y equals arccosine of x, then we know this graph looks something like this. Okay, where this is the point 1, 0. This is the point 0 pi over 2. And this is the point negative 1 pi. And sometimes I get a little shaky on this, so what I have to do is I have to think about what does my cosine curve look like. It looks something like, that's a piece of my cosine curve. And so this was the point 0, 1. This was the point pi over 2, 0. This was the point pi negative 1. And now I want the inverse, so I have to switch my x and my y's. Okay. There's a lot going on here. So hopefully you learned the first stuff well, and so now you can keep going with the inverse. Okay, so this is telling us our cosine, its range is from 0 to pi. So thinking about the unit circle, where are we living? We're living between 0 and pi. Okay, so with our cosine, we have to be in quadrants 1 and 2. And there will be no negative answers. Everything will be, all of your values will be between or including 0 and pi. Okay, where are we? Well, there's the bell again. I have 5 more minutes before I have to go do lunch duty. So when we hear a bell a second time, I'm out. Okay, so on this one, let's look at hers. I liked this. So arccosine of negative 1/2, well, that means I have to live in this area here. Arccosine of negative 1/2, that's going to be here. That's going to be 2 pi over 3. Okay, arcsine of negative root 3 over 2, that's over here. Negative root 3 over 2 is this one. And so that's negative pi over 3. Yes. Okay, arccosine of negative root 3 over 2, this is going to be, I lied, 5 pi over 6. Okay, and now her number 7 matches my, the same idea. No, not quite. Okay. On this one, so now we're saying, okay, arcsine of root 3 over 2, what's the sine value of that? Well, let's think about that for a second. Root 3 over 2 is going to be here. So that's pi over, that's when the y value is root 3 over 2. That's going to be sine of pi over 3. And what is sine of pi over 3? It is root 3 over 2. Okay, so yes, it does look like that the sine and the inverse sine cancel each other out. And It will and it won't. So be careful about that. It will if you're in the world that you're supposed to be in. Okay? So if you're living in this world, they're going to cancel for sine, it'll cancel each other out. If you're living in this world here for cosine, they'll cancel each other out. But check this out right here. If I have arcsine of sine of 5 pi over 6, if I think, oh, the answer, they just cancel each other out, it's 5 pi over 6. Well, not exactly, because that's a unit circle. 5 pi over 6 is over here. Sine of 5 pi over 6 is 1/2. So this equals arcsine of 1/2. Well, arcsine has to keep us living in quadrants 1 and 4. So I don't want the answer that I don't want the answer that's at the dot where I am. I want this answer over here. And so the answer is equal to pi over 6. So notice, I mean, it is convenient. They're in the same family. Like this is 5 pi over 6 has pi over 6 as its reference angle. But if I had said, hang on, if I had said arcsine of 7 pi over 6, okay, we think, I lied. Is that what I want to do? Okay, no, here's what I wanted. I wanted to repeat that process. Arcsine of sine of, okay. This doesn't make any sense. Okay, sorry, my bad. Arcsine of sine of 7 pi over 6. Well, if I think, oh, that's has a reference angle of pi over 6, so my answer must therefore be pi over 6, you're wrong, because what happens here, 7 pi over 6 is in this quadrant, okay? And so the other value would be over here, which it does have pi over 6 as its reference angle, but I want to know when is this value negative, okay? Or another way to think of this is this, I want to find arcsine of negative 1/2, and arcsine of negative 1/2 is equal to negative pi over 6, and so that's the correct answer. Okay. Okay, so this is on the unit circle, so that would give us, this is just a messy video, I'm so sorry. Arcsine of 1/2 is 0.5 is 1/2. Arcsine of 1/2 is equal to pi over 6. So then they're saying, okay, what's cosine of pi over 6? Well, cosine of pi over 6 is root 3 over 2. This one is a new type of problem. I don't remember if I made another video on this, but here we go. What I would do when I see an x or other numbers, if it's something that's not unit circle friendly, then let's draw this and say, okay, arc cosine. So they're basically saying arc cosine of x over 3 is equal to some angle theta. Okay, so let's draw, so that's like saying cosine of theta is equal to x over 3. So if this is my angle theta, cosine is going to be adjacent over hypotenuse, and there we go. So now to find this other side, I have to do the Pythagorean theorem. Let's call this k because that's our favorite letter for right now. Oh, I have lunch duty. Lucky me. Okay, so x squared plus k squared equals 9. So therefore, k would equal the square root of 9 minus x squared. So this side right here is the square root of 9 minus x squared. So tangent is going to be opposite over adjacent. And so the correct answer to this problem, I don't know where to write it, is equal to this. I'm not going to post this document because this is a mess. Okay. This, ladies and gentlemen, is the correct answer. Okay. The other thing that Ms. Deloach did, I'm going to be late to lunch duty. Let's jump to number 10 because that's a little tricky. So we're going to say this is equal to tangent of, well, let's clean up each one of these. Inverse sine of root 3 over 2, that's the y value. This is going to be pi over 3 minus inverse cosine of root 3 over 2 is going to be pi over 6. And so now they're saying, okay, subtract those. Well, pi over 3 minus pi over 6, that's like 2 pi over 6 minus pi over 6. well, anyway, I don't mean to say obviously, but there we go. And so now what is tangent of pi over 6? That is equal to root 3 over 3. So hopefully you have been keeping up with me, because there are a whole lot of pieces that go into making sense of this. Always reach out if you're struggling and have questions, concerns, or comments. Go practice. Good luck.